Good evening, learners. My name is Mr. Poch Lola once again. Welcome to AS Physics, code number 9702. And we begin by looking at a topic called physical quantities and the units. So let me invite all AS students doing physics, but also those doing other syllabus or syllabi like MSCE. You can also benefit from this because the topic also appears in your MSCE syllabus. So this content or this lesson is beneficial to both AS students as well as MANEB students or MSCE students. So without much ado, let us proceed to look at the definition of physical quantities. What are physical quantities in physics? What are physical quantities? Definition. All right. So you may or you might have looked at the definition of physical quantities before in other classes. If you are doing AS, maybe at the IGCSE level, you also looked at the definition of physical quantities, or if you are doing a MANEB syllabus, it's not the first time, my assumption, that you are meeting this concept of physical quantities for the first time. Right, so for the sake of this level of learning of AS physics, and as well as the MSCE level, we are going to define physical quantities in the following manner. So we're saying that physical quantities are those quantities which can be measured in the physics laboratory. So these are factors that can be quantified. They are measurable. You can measure them. All right? So anything that you can measure in the lab, in the science lab, not only in physics, but also in chemistry, in biology, as well as agriculture. As long as the quantities are measurable, we call them physical quantities. So think about quantities such as time, for example. You can measure time of an activity, a particular activity, in seconds. So time, therefore, is a physical quantity. Or you can measure the mass of a bag of sand, for example. All right, you put sand in a small bag and measure its mass, all right, to quantify it. Okay, so therefore mass is also a physical quantity. There are other quantities such as volume of liquids and others. Okay, so anything that you can measure, forces using, for example, a spring balance, all these are examples of physical quantities. So think about physical quantity as anything that you can measure in the laboratory. All right. So all physical quantities consist of a numerical magnitude and a unit. So we are saying that anything you measure in the lab must have a numerical magnitude. Numerical magnitude in this case simply refers to a number. Let's suppose that you're measuring, say, mass of a bag of sand, and you found that it's 4 kgs, right? So in this case, the 4 is a numerical magnitude. This is called magnitude, numerical magnitude. It's a number. It's a number, all right? So we are saying the 4 is a number. It's just a number. So this is a number, and the kg is the unit. So you're saying any quantity that you measure in the lab must have 2 parts. Okay, must have 2 parts. If you don't indicate any of the parts, then it doesn't make any sense at all. Let's suppose that you measured mass of a bag of sand and you found 4 kgs, or just 4. You found 4 kgs, but you omitted the kg there. So instead of writing 4 kg, you write 4 only. That one, the 4, will not make any sense. So in order to fully represent a quantity, it must have a number and a unit. So in this case, an example of a number is the 4, and the unit is 4. The unit is the kg. So 4 kg. Or if, say, for example, you're measuring the length of a ruler. Let's suppose you have a ruler, all right? You're measuring the length of a ruler, or you're measuring the length of a pencil, for example. All right, so measuring the length of a pencil. Suppose this is a pencil. All right, you're measuring the length of a pencil. Okay, let's say this is a pencil. Okay, so you're measuring this length. You're measuring this length. Let's suppose that you found the length to be maybe 8 centimeters. All right, so the 8 is a number which is called numerical magnitude. The 8 is the number. The 8 in this case is the number which we are talking about, and the centimeters is the what? The unit. So any quantity that you measure in the lab must have these two parts: the number, which is called numerical magnitude. Numerical magnitude means number. Okay, so if any of the parts it misses out, then it doesn't make any sense at all. All right, so a quantity which is measured in the lab must have these two parts: a numerical magnitude, which is just a number. Numerical magnitude simply refers to a number, and then a unit. All right, I hope we are together there. So on this slide we have defined the physical quantities. We are saying that it's those quantities which can be measured in the physics lab, or it can also be in other laboratories like chemistry laboratories, biology labs, in science in general. So that which you can measure and you can quantify it is called a physical quantity. And so we are saying a physical quantity must have two parts, namely a numerical magnitude and a unit. So physical quantities can be classified into two. The first type of physical quantities is referred to as basic physical quantities. Basic physical quantities. So what are basic physical quantities? All right, we define physical quantities, basic physical quantities, as physical quantities which do not require other quantities in order to express them. All right, so we don't need other quantities in order to express basic quantities. In other words, these quantities are independent of other physical quantities when being expressed. Let's say that you are measuring mass of a substance. So you use a beam balance to determine the mass of a ball, or mass of a coin, or mass of any other body. It is going to be in kgs. You read off from the measuring instrument and record the mass as maybe 2 kgs of 100 grams or 50 grams without having to refer to other quantities in order to fully express the mass. So any quantity which does not require other physical quantities in order to express it or to express it is called the basic quantity. Basic quantity. So we are saying these are independent. In other words, they don't depend on other quantities in order to fully express them. So they are called basic quantities. All right. Alternatively, you can also call them fundamental quantities. So if there's a question requiring you to define fundamental quantity, physical quantities, that is the same as asking you to define basic quantities. So basic quantities are also called fundamental quantities. Very important to note. So the units of basic physical quantities is what is known as SI units. It's what is called SI units. So we refer to base units as the units of basic quantities. Please don't miss this point. Base SI units are the units of the basic quantities, or the units of the fundamental quantities. We have some examples which we are going to look at. So we are saying basic quantities are those physical quantities which do not require other quantities in order to express them. They are independent of other physical quantities when being expressed. All right, so they are also called fundamental physical quantities. So we are saying that, and you need to understand this very well, that the units of basic quantities are called base SI units. Right, so in physics there are 7 basic quantities. There are 7 basic quantities. These you need to memorize, and you have, for each you have to know, for each quantity you have to know the SI unit, and as well as the symbol of the SI unit. So this table here gives you a summary of the physical quantities and their SI units. All right, so we have mass. Mass is measured using a beam balance in kilograms. So the mass, the SI unit of mass, we are saying, is the kilogram. In short, the kilogram is written as a kg. Take note that the k ought to be small. All right, so small k and small g, not capital K. All right, as shown there. Okay, length is measured using many instruments. You can measure length using a ruler, measuring tape. You can measure length using very high precision equipment or instruments such as vernier caliper or micrometer screw gauge and others. So length is measured in SI units called the meter. The meter is represented by the symbol M. Time, which is measured using a stopwatch, okay, is measured in seconds. The symbol for second is a small s. Please take note, because if you use the capital S, it means you are representing something else. For example, displacement in physics. Okay, and then we have temperature. Temperature is measured in what is known as the Kelvin. Take note that the SI unit of temperature, which is in some cases referred to as the thermodynamic temperature, is the Kelvin, not the degree Celsius. Okay, so the Kelvin, in short, is capital K. Please take note that when you are writing the unit of temperature as Kelvin, the K in this word Kelvin must be small letter. But when you are writing it as a symbol, it has to be capital letter K. In fact, the rule is that if the symbols, rather the units, the SI units are named after the names of people, the name of the unit should be should start with a small letter. But when expressed or written in short, the symbol should be capital. So, for example, Kelvin. Kelvin is a name of person who made contributions to physics, especially to the study of thermodynamics, and so the unit of temperature is named after him as Kelvin. So in symbols, just write K, capital letter. Another one is electric current. Electric current electric current is measured in the units called ampere, or some say ampere. All right, ampere. So the A, when you're writing this in full, has to be a small a, but when you written in symbols, it has to be a capital A. Luminous intensity is measured in units called candela, and its symbol is CD. Amount of substance is measured in what is called moles, and the symbol is a mole, M-O-L symbol. But when written in full, it has to be M-O-L-E. So I'm saying that make sure you memorize this table, know the physical quantity, its SI unit, and the symbol of the SI unit. So what you need to take home is the fact that there are only 7 of them. Basic quantities are only 7 of them. There are no more than 7. At this AS level, you should be familiar with the first 5 very well. So we are going to deal with these 5. Okay, we'll make reference to these 5 physical quantities, the first 5. The last 2, luminous intensity and the amount of substance, are not dealt with at this AS level, or even at MSc level. Of course, at MSc level, you also talk about them more, especially in chemistry, when you're looking at a topic known as stoichiometry. But at AS, we don't make a reference to these 2 in physics. All right, so I think you're good on these 7 basic quantities and their SI units. Remember, if you are visiting this site for the first time, to subscribe so that you don't miss any content as it is being uploaded. Right, so you need to note the following. Note that when we say SI units, SI is not an English abbreviation. It's actually French. It means Système or Système International des Unités, which means International Systems of Units. Okay, International System of Units. So these are carefully defined units that are used throughout the scientific world for measuring all quantities. So the whole world uses SI units. Where science is taught, SI units are used. That's why they're called international units. Another important point to note is that the amount of substance and the luminous intensity will not be dealt with at this AS level until you reach the A2 level. A2 level is the last part of the A levels physics. Okay, so if you are doing A levels, first you do a syllabus which is called the AS, and which is half of the A levels, and then the last half is called A2. So you start, you actually, in as far as physical quantities are concerned, you just deal with the first 5, the ones that we have shown in this table: mass, length, time, temperature, as well as electric current. But luminous intensity and amount of substance are not dealt with at this first half of A levels, which is the AS. I hope so far so good. Don't forget to inform your friends to come and learn on this platform. It's all for free. You don't have to pay anything. But in case you need these special programs, special lessons, private tuition, feel free to call the number that has been given. One of us on Black Slides will be able to talk to you, and you can arrange some lessons online. Okay, that's very good. All right, so other than basic physical quantities, another type of quantities is called derived physical quantities. The word derive means to obtain something from another. Okay, derive, to obtain from. Okay, so derived physical quantities, definition of derived physical quantities is that these are physical quantities which are combinations of basic physical quantities. Once again, derived physical quantities are combinations. So they are combinations of basic physical quantities. You combine two or more physical quantities as long as they make sense. What you get is another quantity known as the derived physical quantities. So you obtain something. You obtain a quantity by combining several physical quantities. All right? By combining several physical quantities. Right. So to obtain derived physical quantities, you either multiply or divide. So derived physical quantities are obtained by multiplying or dividing basic physical quantities. All right, by multiplication or division. Okay, but you do not obtain physical quantities by addition or subtraction of basic physical quantities. Okay, so this means if you have, let's say, 2 kgs and another 2 kgs, you don't get a different quantity. You still get mass, let's say 4 kgs. This is equal to 4 kgs, which is still mass. Okay, but if you look at, say, a body which is covering a distance, a body covering some distance from point A to, say, point B, okay, such that it takes a time t, all right, assuming this is d, distance, the distance covered. Okay, all right, so the distance covered and the time taken to cover it can give us some idea about how distance is changing as time is changing. We call that speed. Speed is simply distance divided by time. So here we are dividing. We are dividing one quantity by another quantity. We are dividing distance by time. It will give us speed. All right. So therefore, speed is a derived quantity. Another derived quantity is, suppose we have a body which is being moved in a certain direction by applying a force F, assuming that the body has a mass of A. Okay? And so we want to determine the magnitude of the force. So the magnitude of the force F will be equal to the mass of the body M multiplied by its acceleration. Remember, acceleration is the rate of change of velocity of a body. Okay, so here we are multiplying mass and acceleration to obtain force. Therefore, force is a derived quantity. It's a derived quantity. There are many examples that you can think about. All right. So before we proceed, we are saying that derived physical quantities are obtained by combinations. Just combine two or more variables or basic physical quantities. What you get is derived quantity. There are many of them. Think about quantities such as power. Power is energy transferred divided by time, or work done divided by time taken. All right, so we have power. To obtain power, we have to divide energy transferred or work done divided by time. We are dividing two things here. Okay, but the energy is also the same as work done. So work is force multiplied by distance. So this distance is what? Distance is a basic quantity. And remember, force, we said force is what? Is mass times acceleration. So mass times acceleration times distance. It will give us what? It will give us work done. Work done. All right, so you meet a lot of these in your AS course, where you have to combine a number of quantities, basic quantities, in order to obtain derived quantities. Let's look at an example where we have to derive basic units from a given derived quantity. So we are saying the unit of force is the Newton. That's that you learned from lower classes, that you can measure force using Newton meter, or the spring balance in short. So the unit of a force is the Newton. What is this in base units? So what we're saying is, this is a derived quantity. We want to express this in base units. Okay, so in order to do that, you should know the definition of force. What is force? Of course, you learned that force is a push or pull, but a more precise definition of force is that force is equal to mass times acceleration. Okay, from your IGCSE physics, you learned that force is equal to mass multiplied by acceleration. So we want to express the units of force, which is the Newton, to the units of mass multiplied by the units of acceleration. Okay, so whatever we obtain here will be the base units. We'll have, by that time, we are going to have expressed the Newton in terms of its base units. All right, so we know that mass is in kgs. That's what we know. All right, from the previous table slides, that mass is in kilograms, and we also know from somewhere that acceleration is in meters per second square. Be familiar with the different ways of writing per second square. You can write this as m stroke s to the power 2, or if you don't want to do that, you can simply say m s to the power minus 2. Similarly, if you want to say meter per second, you can write like this, but you can also write m s to the power minus 1. In case you're not familiar with this version of writing the units of acceleration. All right, so we have unit of mass here, we have unit of acceleration there. So the next thing we can do now is to go back to the definition of force. So force, the units of force, therefore, will be the units of mass. This is mass, by the way, multiplied by the units of all of this is the unit of acceleration. So easy to do. That's why I keep saying and I advise my students to always recall what they learned at the lower classes, in this case IGCSE classes. All right, so this brings us to the end of lesson number 1. It's just the first lesson. We have so far looked at the definitions of physical quantity, and we've said that a physical quantity must have two parts, namely must have a numerical value or a numerical magnitude, which is just a number, and the units. And we've also seen that physical quantities can be classified into two, namely basic physical quantities and the derived physical quantities. Basic physical quantities do not require other quantities in order to fully express them, whereas derived physical quantities require basic quantities in order to express them. So there are two things you can do to basic quantities in order to obtain derived quantities. It's either you multiply quantities or you divide quantities, but not adding or subtracting. All right, so thank you very much for being there. It has been a pleasure to share with you this, and I look forward to meeting you again in lesson number 2 of the same topic. But let me leave you with some work to do in your own time. Define or what is required to express a physical quantity fully. Okay, so we mentioned it in this lesson that in order to express a physical quantity fully, you need two things. What are these two things? What are these two things? All right. Okay, so which of the following are base quantities? The base quantities or basic quantities. All right, so we have time here, we have time, we have speed, volume, and energy. So all you have to do is which one belongs to the list of those seven quantities, and then you should be able to pick one. Okay, which of the following are base units? Please differentiate very well between basic quantities and base units. I mentioned that base units are the SI units of base quantities. All right, so which ones are the base units? So you have a kilogram here, you have a kilogram, we have a meter squared, I think meter square is 1, and then you have a joule and a Kelvin. All right, so be able to answer these questions based on what we have shared. Last but not least, the unit of potential difference is the volt. Give this in base units. Remember, potential difference. What is potential difference again? Potential difference, or what we call voltage. So review your work. Voltage, potential difference, is work done divided by charge. So start from here. Start from here and see how far you can go. So in this case, you have to work out the units of the work done, which is a joule, and the unit of coulomb, which is the unit of charge, which is the coulomb. And then proceed. It will be interesting to find the units of voltage or volts in base units. All right, so once again, let me leave you with this work to work on that, work on these questions, and don't forget to subscribe to the channel and also share with me the answers by simply you can just share the answers to the number shown, or better still, just comment on the comment section on this platform. But in case you need some lessons in chemistry, physics, biology, mathematics, and other areas in science, we are there for you. Just let us know, and we'll be glad to come back to you. For now, bye-bye.